Hello everyone. This video is going to introduce the concept of abbreviated or condensed electron configurations for atoms. But before we talk about how to do that, let's just review the concepts of electron configurations we've talked about before. So in this previous slide, we gave electron configurations for the elements of Se and Y. And we used the periodic table to determine those orbital designations, or that electron configuration. And so you could see that for these two elements in particular, and especially as you travel through the periodic table, the more electrons that you have to place in your electron configurations, the longer your electron configurations, or the longer your address for your atom becomes, because you have more electrons to place. So giving electron configurations for elements like lithium or beryllium, those electron configurations are pretty short, but as you travel through the periodic table, these electron addresses get much longer. Your wrist starts to hurt a little bit if you're writing them. So there is a way to write electron configurations that are abbreviated, that are condensed. We use abbreviations all the time in addresses. Instead of writing out the word street or avenue, we do the abbreviation ST period or AVE period. We can do something similar with electron configurations. We can write something that is called the abbreviated electron configuration. And so to write the abbreviated electron configuration, writing that requires you to put in brackets the closest previous noble gas, and then you write the rest of the electron configuration as it is in the full or the regular electron configuration. For example, fluorine. If you were to write the full electron configuration for fluorine, which has 9 electrons, you would give it as 1s1, 2s2, 2p5. That would be the full electron configuration. If you were to do the abbreviated electron configuration for fluorine, you'd look at your periodic table and you would look to see what the closest previous noble gas is to fluorine. You'd look at your periodic table and you'd see that the closest previous noble gas is helium. So you put helium in brackets for that abbreviated electron configuration. And doing that takes the place of the 1s2, because what is the electron configuration for helium? It's 1s2. So you put the previous noble gas in brackets, and then you write the rest of the electron configuration as you would normally. In this case, 2s2, 2p5. If I was to write the abbreviated electron configuration for chlorine, looking at your periodic table, what is the closest previous noble gas to chlorine? The closest previous or prior noble gas is neon. And when you put neon in brackets, that is the same as saying in the full electron configuration 1s2, 2s2, 2p6. So you put neon in brackets, and then the rest of the electron configuration is the same as it was in the full electron configuration. In this case, 3s2, 3p5. Okay. So in abbreviated electron configurations, we use the symbol for the previous noble gas first, put that in brackets, and then the rest of the electron configuration is the same. So these electrons that are part of the previous noble gas, these are called core electrons. And the reason why we call them core electrons is because they're closest to the nucleus. What's important about those electrons is they are not involved in reactions or in forming ionic or covalent bonds. Electrons that are involved in ionic or covalent bonds are those that are furthest away from the nucleus, so they are most accessible to other atoms in bonding. those are called valence electrons, and it's the valence electrons that have the highest principal quantum number, n. And it's the valence electrons that are written explicitly in both the abbreviated and full electron configurations. So hopefully you can see that looking at fluorine, how many valence electrons do I have? Well, looking at my abbreviated electron configuration, I have 5 electrons in the 2p, 2 electrons in the 2s. So fluorine has a total of 7 valence electrons. I can say the same thing for chlorine as well, because those are the number of electrons in the highest principal quantum number. Okay. We're going to revisit core and particularly valence electrons in the last video, but to end this segment, let's practice doing abbreviated electron configurations for these 2 elements that we did full electron configurations for previously. So for SE, to give the abbreviated electron configuration, so here's SE right here. What is the closest previous noble gas? Closest previous noble gas is argon. So I'm going to put AR in brackets. And then I write the rest of the electron configuration as I would normally. So it would be 4s2, 3d10, and 4p4. So that would be the abbreviated electron configuration for SE. For Y, to do the abbreviated electron configuration, I got to start with the closest previous noble gas in parentheses. Here's a Y right here, the closest previous noble gas. Closest previous noble gas is Kr. So I put Kr in brackets. And then I write the rest of the electron configuration as I would normally. 5s2, 4d1. Okay. So that is how you write abbreviated electron configurations, and those can be particularly helpful for you and for your wrist if you have to write the electron configuration for an element that has a lot of electrons.